And it begins. Oh, I should close this. Hold on. Wait.
Oh my god.
It has begun. Okay, I know. Sometimes it behaves really weird like. So let's get started here. Geometric sequence. Yesterday we did, not yesterday. I didn't see you yesterday, did I? Monday. Well, I saw you, but we didn't do a lesson. So Monday we talked about the arithmetics. I think Thomas pointed out with the arithmetic, you're just adding a common difference, right? So you're adding 50 or you're subtracting 50. It's just some quantity that you add that makes it different. And of course you can't add negative numbers, so you're just adding some difference there. For this geometric sequence, we're going to be obtaining the next term by multiplying. So it's going to be a product here, preceding the term by a fixed non-zero constant. You can't multiply by 0 because otherwise everything would just be 0, 0, 0, 0, 0, 0, 0.
What section is this?
This is the one on geometric.
10.3.
What?
10.3.
0.
I thought it was 6
I need you.
This is 10. This is chapter 10.
This is 10.3.
Yeah, we're on 10.3.
Before we used to call that difference the common difference. Here we're going to call it the common ratio that we're multiplying by. It's going to be the common ratio. Okay.
Wait, this
Arithmetic.
is that like, does differ from the common difference?
Common difference is for arithmetic sequences. The common ratio is going to be for your geometrics.
Okay.
This is 10.3.
Yeah, we did 10.2 in there. Yeah, we did. It was not too bad.
It was.
This one's pretty good because we've done this. You should have done this already, especially if you were in honors honors algebra 2 last year.
Yeah.
You should have covered these. So that's why I don't feel uncomfortable kind of pushing through.
And so the common ratio is like,
It's the product. It's what you're multiplying by to get to the next number. Here. So here's an example because I know you're a very visual person. Write the first 6 terms for the geometric sequence. They're saying the first term is 12. Okay. So that means that a sub 1 is 12. To get the next one, I'm going to multiply 12 by a half, which means the next one's 6. A sub 3, what's half of 6? So there's a sub 3. Half of that is going to be 3 halves. Half of that is going to be 3/4. Yeah? And then finally, of course, the 6th one would be half of that, which would be 3/8. So you're just multiplying the last one by that common ratio, okay? Which would be, in this case, a halfer. This is so difficult.
Yeah.
My mustache is getting longer. It's getting into my lips and it's getting into my mouth. So I'm trying to like move it away, and I try to wax it.
Trim it.
Yeah, move it. No, you're not supposed to.
Oh.
And then if I
So weird about it. Weird.
I don't know. I almost took it off on Monday. I had the clippers and everything, and I was like, no, wait.
your hair grows in so dark that it looks better. You look better with the beard because it grows in so
But I look like a freaking lumberjack.
What's wrong with that?
Where's my axe? There's me right there. Me and Louie kick it on Fridays. So for geometrics, here's your explicit formula. They're calling it the general one. I would just say this is explicit. If you know what position you want, then you can just plug it into this bad boy. Can we see it okay back there? Miss Campbell with the laptops open?
That's the.
I just gotta do one every Sunday. Like, I love
That's
it.
what a general.
Yeah, this is your general one.
That's like the format for all of them.
Pretty much. I do need to give you a word of caution, some advice there. Please do not, you're going to feel the urge to multiply a by r and then do the exponent. But what does the order of operations say you're supposed to do first?
Exponents.
Exponents and then multiply. And right now it doesn't look like you're gonna do that, but once you start doing the problems, you're really gonna want to do it, and it's gonna be wrong. Can I change the slide?
No.
Okay, I wasn't going to. Just kidding. I'm just gonna check the time here.
I want ceviche.
Ooh, that sounds so good.
What?
I really go for some ceviche.
Oh, ceviche.
Yeah, sometimes it feels like
I'm not gonna lie, I'm not the biggest fan of
I want some
ceviche.
tacos.
Ooh.
Some tacos de cabeza and some lengua.
Ooh.
A little bit of everything. Some sesos.
Al pastor.
I like pastor, but
what the heck is that?
it's just pork with seasoning on top.
Yeah.
It's the way it's prepared.
Yeah.
Al pastor, it's done on a spit and it's slow roasted. And adobada, you don't have to do it on a spit. You can just do it on a cazuela and you throw in the sauces and stuff, the chiles. And it's the type of chile that you use as well. But yeah, I have questions like that. Because like,
They're the same.
in Mexico we have like a lot of plates that have different names and they're essentially the same thing.
Yeah.
Like,
You know what this is?
Like if you're gonna get a quesadilla, oh, that's a tortilla. You throw some meat on it and maybe some cheese, right?
Maybe some cheese.
Well, not my bad. For quesadilla, you do cheese. You throw some cheese on there. Well, we count caramelos if you use a flour tortilla. If you're gonna make some chilaquiles, oh, that's just tortillas. You throw some chile on there. You can throw some cheese on there, and maybe some meat. Tacos, oh, that's just a tortilla with some meat on there. You can throw some lettuce and maybe some cheese in there. Everything is tortillas and meat. To cook?
He's like,
No. My favorite thing to cook. I'm a breakfast guy. I love making breakfast.
I'm a dinner guy. I don't
Okay.
really like breakfast.
So, check this out. Ow! Oh, I got it with my little knuckles. Find the seventh term of the geometric sequence whose first term is 5 and whose common ratio is -3. So, oh, you guys want to try first?
yeah.
Okay, go for it. You can do it.
Seventh term?
So, for the in and out thing, we just show them the flyer.
Or you can tell them, I think. You have to have the flyer? Really? That's not cool.
You guys want to know how to get the cheapest milk?
Yeah, be careful with Jen. She says I got flyers, but she got posters.
I paid $4 for
I need one.
Okay, I did it. Is this supposed to be big?
What?
Is it supposed to be a big
It
number?
can be. Let me find it for you. Probably a small number.
I got 3645.
Maybe a small
I
number.
got 3645.
3645.
Yeah, that's what I got. I got 364.
Yeah. You're good. I was thinking, never mind, I don't know what I'm saying. Because because it's 7,
Yeah.
it's gonna be 7 minus 1, which gives you a positive exponent.
Yes.
So it should be a big positive. But if it was 8 minus 1 makes 7, which would give you a very big negative.
Graphed it. Like I said, push right.
Right? Yeah, because it can go up and down. If you were graphing the values for some reason.
Plug it in, so you would put a sub 1 versus 5 times.
Thank you. So,
And then you would use
we have the formula. It's pretty explicit. A sub n is equal to A sub 1 times the common ratio, position minus 1. Position minus 1. So as I write this, I want the 7th term, correct? So that should give me 5 times the common ratio, which is -3. And then you're going to have 7 minus 1, which ends up being, but you see what I'm talking about? A lot of times you're going to see this, you're going to want to go, oh, 5 times 3 is -15.
Yeah.
Don't do that. You do that, you fools. You're wrong. You just lost points. So 5 times -3 to the 6th. What's that? What's that right there?
That is
Some very big positive, right?
it's 729.
729.
Yeah.
Yeah, I gotta go 7 minus 1, right? Position minus 1. And then finally, 3, 6,
4, 5.
4, 5. Please verify you got the correct one. Any questions? This is so difficult.
My ankles.
We're good? Alright. Let's have you guys try to make the formula. Here is a piece of a sequence. I want you to write the geometric equation to this, please. Once you have that, then I want you to find your own 8th term. And I'll tell you what it's going to be. The 8th term is going to be 384. That's just so that you can check that you did it correctly.
Wait, was it 8 term?
The 8th term will end up being 384.
Wait, so he's back to 4.
Hey, you that was throwing stuff.
Oh, dang. Can I have one?
Was he blaming you?
Can I have one?
You owe her an apology.
She looks in my backpack like every day.
That doesn't mean she stole anything.
She does.
You look at my desk over here all the time. Should I blame you for everything that's disappeared?
I don't walk over there though.
Oh.
I don't rummage through it.
Sorry, I had to just have that.
Isn't it like Ace of 1, 2, and then there's
I don't know. Talk to your neighbors. See who listen to that backpack.
2? We keep 2. Oh, Ace of 1.
That's a sigma. That's a summation. To actually do one, you're going to want to be in a calculator because so you're going to want to be in there, and then you're going to go into the menu, and then I believe it's going to be. I want to say calculator. Yeah, there it is. It's a calculator.
I got it right.
Don't they have to pick you when you're like in 8th grade? They have to be like, oh, we like.
Is that the only one you didn't check? Is that the menu that the only menu you didn't check?
Your brain works will make you recognize. I don't think you can become a rocket scientist. I think they have to pick you.
I got it. Figured it out. It wasn't that hard.
Some of the government.
Oye, ¿cómo va?
The government has to be like, oh, we like your thinking. Become a government. I think they pick you when you're like in 6th grade.
Those 2. Yeah.
How do you, like, is there another way you can find it? Because, like, what if it's not as obvious what the common difference is? Like, what if it's, like, square root of 3 over 2?
The question's wrong. I don't work at anything like that. That's wrong.
Because we have
You know?
What?
Like, what, how do you, is there a different way you can find the common difference? 'Cause, like,
This is not a common difference. This should be a common.
But if another common ratio, right? Like, what if it's something like square root of 3 over 2? How do you find?
You would take what? To find the common ratio, you're going to take the second value and divide it by the first value.
Oh.
That will give you the common ratio. And it should work for all of them. It doesn't matter which two you take,
And then if it
as long as you
doesn't,
do one before the other, because it is a common ratio. That number should be pervasive through the whole thing.
but then if it isn't, then that means that's not a sequence. And we'll probably get into that later. You're not watching.
Who got my formula?
I confirmed it.
3 times 2 is 6, right?
Yeah.
What? It's not?
3 times. Yeah. Yeah, it is.
Yeah.
3 times 2 is 6.
The correct one is the top. Do not make the mistake of wanting to multiply the two, because that would not be correct. You would not be following the order operations.
Wait,
Was I?
384 is the 9th term, not the 8th term. No, it's 8th term.
Did you go minus 1?
6. What? Like 48 is the 6th term. Yeah. Oh wait, no, that's 5th term. Yeah, it's the 5th term.
I can continue?
Yeah.
We're good?
No.
We're not good. The top one, not the one that I crossed out. And then the 8th term I told you was 3 to 4.
Why? They're supposed to be.
What? Well, you need to find the full formula, right? And this is a sub 1. Well, a sub 1 was given to me. That's just 3. Then to find a common ratio, 6 divided by 3 is 2. That goes here, which is r, to the n minus 1. Yeah, I guess that is the hardest part of this, correct. And then you want to figure out what the 8th term is, which means you'd have to do this, and then take 2 to the 7th. Because 8 minus 1 is 7. Yeah? Okay. Now that we can do this geometric stuff, we want to find the sum of a bunch of them. Help? Yeah. Is that what you said, or did you just burp? Okay. So, here's your formula for that. To find the sum of the first n number of terms in the geometric sequence, you're going to take a sub 1. You're going to multiply it by 1 minus the ratio to the nth, and then divide it by 1 minus the ratio. So it's a little bit, I don't know what the word I want to use is. No, not really. It's just fractions in there. It's tedious. There you go. That's a good word. It'll be a little tedious, but it's not hard work. Okay. Now, just a warning, the ratio cannot be 1. Someone tell me why.
Because it can.
Because you said so?
All the numbers should be like 6, 6, 6, 6.
Say that again, nice and loud.
It'd be a 0 on the...
You'd have a 0 on the bottom. 1 minus 1 gives you 0. And if we have that, then undefined. So just restriction, the common ratio cannot be 1.
Can you do one?
No, you will. Everybody have this formula? Everyone got the Kirchner-Crab formula?
If you look up the Krusty-Krab formula on Google, you see like all this stuff.
Yeah?
Pretty funny.
I never thought about doing it.
It says it has like
Krabby Patty?
I watched...
I don't know, Mr. Krabs is kind of shady guy. So.
I have a thing saved on Instagram. It's like a little short.
Maybe he killed all the other guys.
He is the only one. You see him in that big
Yeah,
black guy.
yeah. Well, no, he's a lobster.
Oh, that's true.
He's the only crab there. No, he killed all the other crabs in the ocean. Because William just pointed out he's the only crab there.
Yeah, we should actually
Okay, try it. Try it out. Take it out for a test ride. Find the sum of the first 9 terms. I need a sound.
They're like, just get a microphone that has like a very low spicy explosion.
Yeah, me too. I thought they were creepy.
Yeah, it was like...
No, I just realized they're all sponges.
when you're starting, do you have to find the regular formula first and then do the sum?
Right, because you're gonna need
You can't just start with the sum.
because you need the common ratio. Not really. You don't need the formula. Because yeah, all you really need to find is the common ratio. That shouldn't be too difficult because it's gonna be.
It's a sub 1's time,
What is it,
1
negative
minus
3?
r.
Yeah, it's negative 3.
Throw this in Yahtzee. We were having a good time. Sure, just trying to.
What do you plug in for N?
The 9.
The position.
Oh.
9th term.
I didn't want to erase her signature, but I ended up doing it. What's up, man? Perdonera. Joaquín, abre la cabeza con eso. Position. 9. What?
I don't think I'm gonna get it right.
I think I got it. What'd you get?
left.
Yeah.
Hey, you bully.
Hey, wait, you live right by me.
I hit my
Ah, my knee.
If you have a ride, I'll take you over there and I'll get you.
So what do we want? What do we do? Sum up the first 9? So we have 2 times 1 minus negative 3 to the. Is it minus?
Yeah.
So is that what you got set up?
Yes.
Okay, so we've got 2, 1 minus.
3.
That's a big number.
No, you'll make
What's
it
3 to the
positive.
9th?
It's negative 19683.
1, 8,
19683.
1, 9.
863. 1, 9, 8.
668. It's 19683.
Oh yeah.
That right there?
19683.
1, oh my God. 19683. Okay, so that means we're going to get 2 times 19684 divided by
Over
4,
and then I just did that.
and then that's going to give you 2.
And then
So what's half of that?
9842.
What was it, 9842?
Yeah.
Do the noise.
Hey, that noise is more annoying up here. 9482, we're good?
98.
9842, sorry. I'm illiterate.
You're illiterate.
Bye, Mon. We're good?
Oh. What'd you get 4? Oh, 2. Oh, 2.
Negative, negative makes a positive.
Oh, you're right. I forgot, dude. I couldn't make it.
Okay? Alright.
I wrote it there.
So do you guys remember compound interest?
No.
Yeah.
Remember the word.
What was simple interest? A equals P times 1 plus R over N to the NT. Was that our, that's our compound interest,
probability,
right?
wasn't it? So isn't that from probability?
No, this is from,
I can't remember where it's from.
no, this was from, thank you. This formula was from interest. We're trying to find interest. So it's compounded interest, and we can compound monthly, annually, weekly, daily, and then we have continuous compounding, right?
Yeah.
Okay. Now, let's say that you are compounding something, but you're trying to figure out what the value of the annuity is. I'm not a big income person, so if anybody can tell us what an annuity is, what's an annuity? To the NT. Well, here's the formula you really want. Don't bug out, because it has this piece in it.
I've seen this before.
Okay? If P is the deposit made at the end of each compounding period for an annuity of R% annual interest compounded 10 times per year, the value of the annuity after that many years. That is a particular one.
Well, our learning cancel.
No, they don't.
No. What if they did?
A is a yeah, you are. Compared to me.
Yeah, what's an
It's a rating in
Ah. Oh, like.
I find that these are pretty self-explanatory, and because today's a short day, I want to get it done. The next slide is just a practice problem, but I definitely want you to get this formula. This is the sum of an infinite geometric series. This is the sum of an infinite geometric series, which is kind of mind-blowing that
Would it just be infinity?
No, not really.
Infinity plus like.
You should be able to find the sum. This is the sum of an infinite geometric series. Dot, 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 that means it goes on forever. Well, that's just the end of the sentence. Understand that an equation is an expression, and that's the end of the expression, therefore it's period. Period, not doesn't point. No, but math is English. That's all written in English, bro. What are you talking about?
No. Ace of
English
one.
is
Yeah, but we don't get foreign language. I've been making that argument for years. I've been making that argument for years. If math is a universal language, why do we give our kids double credit? One for math and one for foreign language?
That's a good question.
I don't know.
What letters A, B, C, D?
Music can convey meaning and stuff. You know what I mean? Like it can convey emotion. You can communicate in music.
You can
You're
play.
angry, whip out the blood and the bumblebee, go out.
Thank you. You guys got this copy down?
Or is it like?
Let's take it for a test drive. Find the sum of the infinite geometric series. 3 plus 2 plus 4 thirds plus 8 ninths. Blah 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 blah.
Find the sum. So I have to find Wait.
Remember to remind your students. Someone said to me, remember to remind your students. Like,
Wow.
tomorrow's AC Merit again.
Rub that on. To remind.
So tomorrow you guys are doing 2, 4, 4, 6.
Oh yeah, we're in here twice as long. We're like we're in here for 2 hours and then we're in here for
So tomorrow
35
2,
minutes.
maybe 3 lessons.
Shit.
I don't think I can do math for that long.
I don't know if I can math that.
We'll pause. Come on now. Well, I'll give you a 5-minute passing period. You can pass around in here.
It's like,
Just like bumper cars.
What's the common ratio here? 2/3.
Oh, the common ratio, yeah.
okay, I got it right.
If it's infinite, then is the sum just like a round, like a,
Integer?
is it like about, is it like about the sum, or is it the actual sum?
Yeah.
So to find the common ratio, you do
Right?
Okay.
the one after.
Everybody get 9?
Yeah.
Everybody get 9? Okay, good. Now, I'm going to try to explain to you how is it that this actually kind of makes sense. And it really has some calculus to do with it. We're not doing the calculus yet. But if you kind of think about, let's say we had numbers from 1 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Now we have something that's on the small spectrum, correct? But if I go ahead and take this all the way to the other side, and I kind of add those, how much is that? That's 10, isn't it? Now do the next two. Do the next two.
They're all 10.
They're all 10s, aren't they? Isn't that kind of tricky?
Yeah.
So we get 10s, 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 and eventually we get to the middle. Let's see, what do we get? We get a 5, correct? But what's going to happen as we're doing all this, and we start trying to add them, you're going to find that if we are graphing all these points, they tend to move closer to something, to some type of number, regardless of where you're at. So as you approach some number, then that becomes the limit. And even though we don't know that that's what it is, we can see that the sum is getting closer, closer, closer to this number. Hence, that must be, if we get to it, the sum of what we're talking about.
Alright.
Even though it's infinite.
It's in the sympathy.
So at one point,
At some point, all these things are going to kind of converge to some number, which we will conclude, oh, once we do get there, that has to be the sum
So it's the sum of
of this specific series. Because even though this sequence, I mean, if you think about it, is infinite, it's not going to be as infinite as if we did 1, 2, 3, 4, 5, 6, 7, 8, right? That infinity is much larger because we're going to have more integers in, don't we? Here, we're jumping around, aren't we?
Yeah, what if the numbers
There
were
are
getting-
different sizes
what
of
if it
infinities.
was- What if the numbers were like 3, 6, 9, 12? Like, what if they were going up?
Then that
and down?
infinity is smaller because now you're jumping by 3s. So you're leaving out 2/3 of one infinity. And actually, infinity is not the biggest number, guys.
Google.
No.
Google.
It's
No.
infinity squared.
Google.
No. I think the largest number we know right now is called Aleph Null.
Olive Knoll.
Aleph Null. Aleph Null.
How many
But
zeros does that
infinity
have?
goes on forever. How could that be bigger?
We're done, so let me find this video because I can't explain like someone that's trained in this.
Infinity isn't a number, it's a concept.
It is. It's an
So whenever
idea.
kindergartners are like, oh, infinity, this, infinity, that, they're wrong.
Okay. You're wrong.
Really, they're